Right. Welcome to Blueboard Electronics Lab. I'm here to talk about this power station here. It had a problem, and I fixed the problem. And this is a problem that I've seen before here on YouTube. Somebody posted it. I saw it in a review, right? Somebody was revealing the product, and then someone in the comments there mentioned the problem. And it was only about 5 months after me seeing the comment that I got the same issue and I managed to fix it. And now here we are. What's the issue? The issue is you have those bars there, right? Because this one doesn't show the percent. The way it shows the state of charge is not with percentage. You get the bars. And that's about 5 bars there. And the issue is maybe after you've used the unit for like a year or two, maybe even 3, you notice it stops to get fully charged. You only start to get, it's stuck. It keeps charging. Maybe it keeps charging the last bar. Others have reported that they've had the last 2 bars just keeps charging. It could be worse. You can even have just the last bar and never fully, charging. And it gets worse as you use it because sometimes you will start to have the same issue, but you keep using the unit and it keeps getting worse, where initially it was just one last bar, then slowly it's 2, now 3, and then you maybe even just never getting it to charge the first bar. And the issue is the cells go out of balance. Unfortunately, this unit does not have cell balancing. I was shocked when I took it apart and I found out that there's no cell balancing circuitry in there. So shocking. What kind of money saving will make you not put such an important, you know, system? So, anyways, took it apart and I found that it doesn't even have a dedicated BMS. The thing has one board, and that one board is the BMS, and it's also the inverter. One board. If you think that's still a good design, let us know in the comments, because I think it's funny. It's strange that you can have one board, it's the BMS, and it's also the inverter. So whatever your thoughts are on such a design, please let us know in the comments how that works out. I get it. Others will say, well, it means the designers or the manufacturers, whatever you want to call them, thought about the fact that they should, customize the unit based on the model and everything. Yeah, that's good, but let us know what you think, right? So it has no cell balancing. I could not spot any bleed resistors there. It has an IC which manages the charging and discharging. So when you've got any of the groups reach 4.2 or whatever in that range, it stops to charge. And also when discharging, if it reaches a certain point, you get that safety cut off and all your outputs get turned off. You've got all those. Unfortunately, you've got no cell balancing. So as soon as any of the groups reaches 4.2, it stops charging, and that's it. So the more the cells drift, the worse it gets. Now, what is the solution? Well, based on the problem that we found, we know what the solution is. The solution is you need to find your own cell balancing module and put it in there. And that's what I did. I went to AliExpress. Of course, most people may not trust AliExpress, but that's what I did. Went to AliExpress, bought myself an active cell balancing module. We have active and passive cell balancing modules. Passive starts to bleed off some power, some current from the highest cell when it reaches whatever threshold is programmed in the management chip, usually around 4.15 ish, somewhere there, starts to bleed off until all the cells get to the same voltage and settles there. I did not like the idea because I believe when the cells start to degrade, you do get some of the groups discharging faster than other groups, and the one that is discharging faster, I believe the active module, the active cell balancing module, may compensate for that. Yes, it is very little current, but in the long run, it works. For example, you've had the lowest cell reach cutoff point, maybe 2.5 volts, while the others are even as high as 3.7. When you let it sit for a while, the lowest will catch up because the module will get some power, from the high cells to the low cells, and then eventually the lowest cell will go up a bit, and the highest will go down a bit, and they will settle somewhere. And that will give you a little bit of reserve. Maybe you need to run some emergency lights. It works. It works out that way. So I had to go with active cell balancing so that it balances the cells no matter the state of charge. Plus, it's faster because the specific module that I got, which I have shown and I'm showing it now, is 1.2 amps maximum balancing current. Of course, it will not balance at 1.2 amps for every cell. It moves from the highest cell to the next cell and then the next to the next. However that works, if you need any further explanation on that, you can comment and I'll be able to explain. So that's the thing. So I would recommend that you get the active cell balancing module and not the passive, because the active is balancing at any point along your charging process. It could be that you're only at 70% charged, 80, whatever, 40, it will still do the balancing there. So if you've had the unit sitting for a while, eventually all the groups will settle at a good voltage and you'll be able to use it better. So that's the thing. If you have a FlashFish, this specifically is a FlashFish P60. I also had a FlashFish G500. Yeah, I had a G500, which is a 222 watt hours model. This one is a 520 watt hours. So the G500 was 222 watt hours battery capacity. It developed the same problem for the people I gave it to. I gave it to someone. That person used it for some time, and then it developed that problem before this one developed the problem. And we did not know what the issue was. But eventually now mine developed the same issue, and I'm for experiments. I took it apart and I found out what the issue was, and I fixed it. And I hope you will fix yours by, after watching this video. I should point out that you are going to be dealing with lithium cells. That is very dangerous. You need to make sure that you know what you're doing. If you do not have experience with lithium cells, inverters, power stations, anything, if you do not know what you're doing, do not attempt to do the repair. You can buy the module and then take the unit together with the module to the people that repair in your area. Those people understand what they're doing. They'll do it for you. Do not attempt the repair yourself unless you really know what you're doing, because you could start a fire. The other thing I recommend, which I did not do myself, is you can place fuses on all the lines, because as you see the module that I posted, it has a cable. So for this particular unit, for example, it is 3 groups of cells put in series. And so what you have there is you've got those different nodes you've got, they're usually labeled B0, B1, B2, and B3. So the lines that go to the the cell balancing module are going to be in that order: B0, B1, B2. B0 is the negative, the B minus. Sometimes it's B0, sometimes it's B minus. And then you've got the B1, B2, B3. So you're going to have fuses recommended to have anything below 5 amps. Since the module is 1.2, I'd recommend 2 amps. So 2 amps on each of those lines, so that should the module misbehave and maybe cause a short somewhere, it should not start a fire by those cables trying to run the full current. That would definitely start a fire. So you can put fuses on each line, 2 amps each, and that will be safe, because we know we cannot trust these things. But anyway, that is what I did. So if you are able to repair your unit after watching this video, that's good. All right, thanks for watching.